Now in this video, I'm going to show you some of the features of what a micron gauge does. I'm not going to tell you everything, I don't have time for that, but I am going to do kind of a very rough explanation of some of the features. In the video on this van, just previous to this, I showed you some of the features of the S-Man field piece and the micron gauge that's right here right now. This is a micron gauge that's external. I just set up for this test, I put a adapter in the middle right here that with that depressor right there is going to connect right to that fitting. And we're going to read the vacuum at this point right here. This is reading the vacuum at the sensor that's located inside this manifold at this point right here. Our vacuum is being applied right now. This is the 8 CFM field piece. Right now I have the low side closed, the high side closed, and right now I just have the field piece drawing. It is time for me to change this oil. Last night I didn't get home from work until after 10 o'clock and I didn't change my oil. I usually change out the oil here, and I drew up some dye from one of the jobs and it sucked dye. There was some pressure and I got in here, so it's contaminated with dye. It's nice and green right now. It's not clear, it's contaminated. And 2 of the systems I worked on were wet, and so it's cloudy, so it needs to be changed. But that's what I have this big bad boy backup over here for. This is the sacrificial. I call this as my sacrificial vacuum pump that I could get it dirty. This is the one I only use after the system has been evacuated out. There's no refrigerant, there's no to little moisture. Then I turn this one on. So getting back to this explanation, high P, high pot means it's exposed to atmosphere. And right now, how I said, only the field piece is on here, and what I'm testing that my manifold can take down vacuum. So now let's test and add this. Okay, so now I have this vacuum pump is running right now. Now I'm going to open the vacuum to this 3/4 inch deep vacuum rated silicone hose, high flow. Watch the microns. That's the difference. This is the big boys toys. That's very good, but that's the little stuff. Okay, so as you can see how far and how fast it made a difference when you use something through large flow hoses on a very good pump. This would be like your Robin Air vacuum pump. Actually, this is even bigger than a Robin Air flow because this one too has high flow gauges. So here's 1/4 inch, here's 3/8, here's 1/2 inch, here's 3/4. So whatever combination of hoses you want to use on the type of job you're using, you can use any one of these adapters. I could even use this hose, 3/8, and 1/4, and I could hook them both up simultaneously so they're both going to the manifold, sucking through that one for more volume. Now that's more volume, that's not deeper vacuum capability, it's just faster. The micron limitation of this is 30 microns. The micron limitation of this is 3 microns. So we know what our manifold and our micron sensor up to this point is capable of doing with what little contamination of oil I have inside the manifold, contamination of oil and refrigerant inside the lining of here is keeping this from going down any further. Sometimes, say I shut off this little guy right here. So now I just shut off the field piece because I know this type of hose is not deep vacuum rated and it gets contaminated with moisture and everything like that, and this hose is not. You see we already dropped down to 42, and when everything is clean, usually it'll drop down to a 30, 28. Now the limitation, you go, well, Why is this rated at 3 microns, but yet you only could get down to 30 microns here? The limitation is not the pump. The limitation is whatever you stick between the pump and your source of your sensor. The longer the distance, the more losses you will have. The more connections you have, the more losses you have. You have a rubber gasket here, you have rubber seals and gaskets at all the valves. Those are all some loss. You have a little bit of oil that's moisture saturated. As long as it keeps outgassing, this number will not drop. Now the silicone hose is good, but it's not the best. If this was stainless steel line, so there's actually connectors where you could have a different adapter plates, and you could hook up like flared copper lines is really good, or stainless steel. And so if I had a short stainless steel line and I put my gauge set, had no rubber, no fittings, not contaminated, anything like that, and I hooked it directly up to the outlet, you would see 3 microns. But every time you add a crimp or anything with restriction or made out of man-made synthetic material, you will have losses. But as you can see, the difference between this and this, how fast that dropped. So now here's our next test, because one of my subscribers purchased a set of these gauges and he has questions. He tried to perform some tests, and this is to you thank you for purchasing those gauges. I have no affiliation to whoever you purchased it from, but I did give the links to True Tech Tools because that's where I buy my tools online. They're very reputable, and you don't have to worry about any shady stuff or whether they're going to cheat you or it's going to get, you know, anything like that. It's a very, very reliable source. Okay, so right now all we're doing is testing inside the manifold right here and through this one hose. Now I'm going to open up the low side. The low side is going here, and the valves are not connected to the system. They're not screwed down. Both of the high and low, let me unconnect that one. So now they're both off. There's no connection to the system, only through the hoses. So now let's open the low side. So now I know what the capability of this hose is. Now this hose has a little bit of refrigerant contamination, oil that has moisture, so it'll keep this number up for a while. But the longer I keep it on this vacuum pump, the lower this number will go until it comes down to about 30 microns. If you don't have leaks, the oil and contamination or refrigerant that are stuck in the rubber will eventually outgas, and it'll pull back down and you'll show 30 here. So now let's go over to this high side hose and see what it will do. So we don't get any false readings from the low side. We want to know what the high side is. So now we close the low side. You see it drop back down. Now let's open the high side. And you see it drop back down. Now if I was going to stay here 10, 15, 20 minutes, it too will go back down to 40 microns and even 30 microns. But right now, what it's reading is the off-gassing of the surface of the rubber inside, of trapped moisture in the surface, trapped refrigerant in the surface. And once it finishes off-gassing, if there's no leaks, this will eventually pull down to 30 microns too. So now, I'm going to open up the low side. So now we're pulling through both hoses, but we are not connected to the system. And if you remember, go back to the previous video on the Sienna van, and you'll see we left off because I had the recovery unit on here, pulled it down to 800 microns. Our system is already evacuated out and down to 800 microns. So now I'm going to open it up to the system. But first I'm going to turn off the vacuum source. When I turn off the vacuum source, the microns are going to raise because there's contamination inside my hose. Moisture, oil, refrigerant. Moisture, oil, refrigerant. It's only this pulling down this low because the vacuum source is on. Watch what happens when I turn the vacuum source off. Now, unless I have leaks, but this will steady out, this is moisture trapped inside my hoses, and it raises up, and it'll probably go up to maybe 1,000, and 1200, and it might stop right there. But what we're interested in is the system right now. So you see it's starting to slow down a little bit. It's creeping up, but it's starting to slow down. It's not so rapid anymore. So let's get back over to our fittings. Now I'm going to screw the fitting down. Oh, wait a minute. One more thing. Let's get this out of sleep. We're back into high pot. Let's open the BluVac software. And hopefully this works the first time and connects. So there's a little Bluetooth signal flashing right there for Bluetooth, telling me it's on, because you could turn it off and on. Let's connect. It says connecting. It's at atmosphere, 776 microns, and so we're at atmosphere. So now I'm going to connect it up. I'm doing this one-handed, and my thing is not quite located in the correct. Okay, so now I am going to open the vacuum source, and you see as I connected that back up and my depressor was pressing, it totally let air back inside the system. So now I'm contaminated with air and moisture in these hoses, but they're still not turned on or hooked up to the system of the car. Back at 0. It's reading 0. So let's open up the vacuum. And let's see if I could get a shot where you could see the pressures here and the micron gauge here. Until this hits past 29, that won't go all the way. Okay, so I'm opening up the vacuum source. I'll open up both. Now, a warning, a reminder, just to make you remember, if you own a vacuum pump, usually you'll have a purge valve on it. And it's telling you, alert, make sure that you close your gas ballast if it is open. Because at the beginning of vacuum, you always open your ballast to help take the load off the cranking stirrer of the motor, and also bleed fresh air. If you have really wet contaminated refrigerant, they say it helps dry it out and it takes the load off the motor. So we will dismiss this and hit dismiss. And you can see where our vacuum's at right now. You can see where our vacuum's at now. Well, why is this 120 and this 270? You'd say something's wrong with one of these. Well, that's because the sensor for this one is located right by the vacuum source where it's very strong. Then it goes down to a little 1/4 inch restriction to a long hose that is contaminated with moisture in it. And then the sensor is way down here. And if you look down at our sensor, it says 205, 249. So this BluVac and this software are matched up. And this timed out has a battery saver feature, so after 15 minutes it will shut off. It has to warm up. And as you can see, there's a very large discrepancy between what you read here and what you read here, because you have this hose and connections and fittings in between. So now let's turn off the vacuum source, and you're going to see them both balance out. So now the vacuum source is off, and if you could see both of them, that has raised. We're at 600, we're at 600, we're at 700, we're about to hit 700. Now the resolution or the speed of the BluVac is much faster than this thing is. And this has a lot of oil contamination in it from jobs. So this is an unfair comparison, because I would actually have to rebuild these and flush it out with alcohol to clean off the oil off the sensor for the micron gauge. But you could get a gist of how it's working. So we're going to turn back on the vacuum. We have our hoses all evacuated out. It's going down, and I'm going to open it up to the source into the vehicle. Watch the vacuum. So now I have the high and the low both opened up to the system. So now you have two sources of micron gauges. And yes, there is a discrepancy, and yes, I know this sensor is coated with oil and is contaminated. I have not cleaned this one out in probably a month, which is really unusual. I usually do a little more frequent than that, but to say I haven't been busy is an understatement. So that is our vacuum source here, our vacuum source here. It's into the system. Both valves are open up into the system. They're depressing the depressors. Now, there's another feature on this. You can data log and record this. Say you're the owner and your technician is out in the shop, and maybe he's one of those technicians who he's a little new, he's a little green, or sometimes you know he doesn't follow procedures and he's a technician who goes, oh yes sir, everything was great, I did the job, I did it right, you know, oh yeah, I evacuated it for 1 hour. Okay, this is how you can tell. If you're the boss and you're sitting in your office, you can connect up to his BluVac and you can see this on your computer screen in your office while your technician is out in the shop working. You can actually see every one of your technicians' readings. Same with this. You can live check in on your technicians and you can set a name to them and everything like that, and you can record everything that your technician, and when he comes to you and tells you he did something, you can see he did it. But if he says he did something because he's on a bonus plan, or he's getting some sort of you know, money for doing something faster, and he skips procedures but he lies and says he performed the vacuum, this is what you can do. This is data logging. I didn't show you this in the beginning. So this is where we started from atmospheric pressure, and it's over time. You see the timer is down here. How many minutes have we been running? 6 minutes, 8 minute mark, 4 minute mark, 2 minute mark. This actually tells you how long it took you to get to the vacuum, how long your technician had the vacuum on, and it records it. And you could record this and put it in your customer's file if you're paperless like I am, and you can actually prove that you performed the vacuum and how long you performed the vacuum, because it will record the time, and how deep. When you say you got the system dry and you got it down below 500 microns, 200 microns, 100 microns, you can literally prove it because you can record this, data log it, save it in a file, and put it in with the customer's invoice. If you have a technician said he left it on for an hour and he pulled it down to 300 microns, but actually you were looking at it on your office and you see he only had it on the vacuum for 5 minutes and he only got to say just past 29 inches of mercury, and he just started going into 9,000 microns, which is really horrible, and then he shut it off and he charged it, and then the car comes back with intermittent not cooling because there's a lot of moisture in the system, and it started freezing up as ice just after the expansion valve, and then sometimes it would work and sometimes it wouldn't work, or there enough ice built up after the expansion valve where it restricted some of the refrigerant but let it cool, so it just comes out somewhat cool out of that ash because now it's metered to a smaller hole because of the ice formation, and it gives poor performance. You can you could say, hey, this customer came back and you told me you did this for an hour and you got it down to 300 microns. Now it's a week later, it's a hot day, and he has this problem. There's excess of moisture in the system. You're doing this on your time off the clock. Now, you can't do this in all cities, states, and countries and stuff like that, but I know I would be really pissed and saying, you're coming in on a Saturday and fixing this customer's car. You're staying after work, this car came back, and you're putting this on the vacuum pump, and you're gonna sit there and watch this for an entire hour, or you're gonna fix the problem and find it. So this helps you weed out those kind of technicians who kind of like don't tell the truth. And if you're a customer, and you may want to demand this, if they said they did everything right, say, show me the data. And if they can't come up with the data, go find a different shop. Real simple. So I think I about showed you what I want to. There's a lot more you could do. There's many more things you could do on this system. different. You could have different gauges on here. So you have multiple, because I have multiple gauges. I don't have one of everything, I have multiples of everything. Oh, let's see, I'm trying to think. Is there something else I want to show you? No, not at this moment. We're already into 20 minutes on this vehicle. And I'm going to be charging it pretty soon. It's lunchtime now. I think it is 11:16. So this needs to stay on the vacuum until it gets down below 500 microns, and that's going to take a little while because this has like 18 feet, 20 feet of refrigerant lines going all the way down to the back of this vehicle, underneath, then it goes along the bottom, and then it comes back up into the evaporator in the rear, and it has to evacuate all the refrigerant and moisture all the way to the rear evaporator in the rear and pull it all the way forward. Now sometimes if I didn't want to go to lunch right now, I could break out the nitrogen and I could sweep this with nitrogen, and I'd push a little bit of the nitrogen up to like 2 psi through the high side, turn it off, and then draw a vacuum on the low side, and then do that like 3 times, and you would watch this vacuum drop down faster and deeper after performing that sweep a few times if you had a moisture related problem. So that's it for now. See you in video number 3 after I recharge this, and let's go back to the results so you can compare to video number 1 what the readings were to video number 3.